We're in Oceanside, California at the Andersen Windows factory. This is where they build the lift slides, the pivot doors, and even a custom curved serpentine lift slide that's being fabricated right now. And we're gonna walk you through the entire process from raw material coming in all the way to where they're testing it and bundling it up and getting ready to ship out to
one of our projects.
Potentially one of our projects.
Yeah.
But we're gonna start with this section here, which is the wood section.
Yeah, the Andersen wood shop. They have the ability to do an aluminum channel that's wood clad. As a result, we can get extra long continuous pieces of trim without any splice joints, not any finger joints in them.
Which is huge. They have an all aluminum product, they have an all wood product, and then they have an aluminum with a wood clad.
Yeah.
One of the things with their product is they can go really large, really tall, really wide. And in order to get that structural stability, they need to use that aluminum.
Yeah, you can see that in the sample over here on the bench. And so that's the Andersen's aluminum channel with pressure fit wood cladding on it. So in this case, you might call it wood clad aluminum frame as opposed to aluminum clad wood frame.
Going back to the plastic clips for a minute, they actually have two different options. They have this option here, and then they have a similar option here, which this one here is for increased thermal performance.
Yep, you have reduces the thermal bridge behind the wood trim cladding on that aluminum profile.
Which is important depending on obviously what climate you're in.
The maximum dimensions of their wood clad product at 14 feet is constrained not by the individual material property of the aluminum or the wood, but by the fact that there's dissimilar movement in the expansion and contraction of those two materials. So that pressure fit thermal break here does allow for a little bit of movement, but the engineering constraint is that you can only tolerate so much of that. So if you go with the wood clad system, you can get up to 14 feet, and you go beyond that to 16 feet if you're only an aluminum frame.
Right. So while they're essentially manufacturing a lot of these wood products, getting these plastic clips installed and doing all that thermal modification, they're also inspecting the glass. So they don't manufacture the glass here, they work with other glass manufacturers and have it shipped here.
There's a lot of concurrent material streams and procurement happening here. And so while trim and wood profiles are being prepped, glass is coming in, being inspected. And here's an example of a one-to-one printout that they have to check for a curve profile.
I gotta stop you just for a minute. I was staring at this earlier and I'm like, why does that look like I'm looking at a computer screen? It's so bright. And then I realized above me is this like super bright LED light that's making that look like it's printed. And this is actually part of that curved serpentine lift slide system. So there's a radius of 256 7/8 of an inch, and they're taking these panels with this machine here, standing it up and dropping it on, making sure, is it 30.5 inches wide? Does it match that radius? But this is the opportunity to catch those imperfections because it's not in the unit now.
Learning the constraints or the kind of material possibilities within the manufacturing process allows us to push limits when we're doing, on paper in design, like an Echo Pond. So here on the racks that you see, all the material that they're stocking on hand is create a lot of customization without triggering a request for a unique material order from the manufacturer. So understanding the constraints of the production process really allow you to make unique requests that are customizable within their parameters.
You mentioned Echo Pond. This is actually the first view of Echo Pond, which is this insanely beautiful anodized aluminum, which is what the exterior of all of our lift slides at Echo Pond will be.
One of the reasons why this looks so clean and matte is because it's been sandblasted before it's anodized. So the anodization has a purchase on it that gets you this really beautiful matte texture. And this is the furthest you could go within these material systems to get natural finishes.
Behind us, there's this full-scale mock-up, similar to what they did with the glass over there. This is the first look at how everyone on the floor here looks at these projects and goes through step by step and making sure not only is it built the way that is drawn and designed, but it operates appropriately. Yeah. So what they did is they actually took this template, shipped it to the builder, and used this on site so he could verify that this is exactly what he needs on site. And they said that when they roll it up or they unroll it back here, and if there's not boot prints on it,
yeah, they know someone didn't look at it.
They didn't look at it. So they look for the boot prints and of course the signature. And I think what's important to note is that this isn't going to be for every lift slide. It's really unnecessary for everyone.
But it's actually, Andersen does this as a standard practice for essentially anything that's a non-90 degree corner. They're gonna make sill and jam one-to-one template to check and to sign off on site.
Just that extra step to make sure that this is exactly what you're asking for and your site is prepped for it. But this is a first kind of look at how they're managing water. Vincent, why don't we go over to the other mock-up? In simplest form, what we're doing is we're capturing water within the track system and getting it out with these tubes. But you have to think about that from an architectural standpoint.
What's ingenious about Andersen's product here is that they're integrating the weep and drainage into the rails for the lift slide. The channels, they actually have a stainless filter screen in there so it doesn't fill with debris.
Right here, where this is actually plexiglass, but that would be essentially our finished surface.
Yeah, so in our case, that's concrete that'll match the structural slab.
But it could be wood, it could be tile. All that ends up sticking up above the finished surface
is this
if you look really close, there's a line about 3/16 of an inch below the top of the track. This is the critical moment when you're on site setting this.
So what I thought was interesting about Andersen's approach is there's going to be margin to adjust in the field. You know, the jacking screw here is a brilliant integration. You know, a lot of times this problem of adjusting frames over large openings or headers that are sagging, you'd handle with like a long screw that you're driving in to take the wonk out of that deflection. But in this case, it's built into the frame.
So what you're going to be doing is you have a hole here, it looks like about a 1/4 inch, but you can fit a 6mm Allen wrench inside there, and that will allow you to adjust this in and out. So if you're trying to plumb this up for a jam or on the header, you're able to jack those in and out, get them tight against the framing, and then you're driving the screw essentially through that plastic jacking
screw. And they have a similar approach on the sill where, and this would be set on all thread. And so if you have a very tall unit, you can imagine being a 16th out at the floor puts you out a 1/4 inch at the header. So by using a similar approach with the sill assembly, you have that fine tuning over the all thread.
There's really finite adjustment into the base of that door, and that's really what sets the stage for the accuracy and essentially the performance of a door like a lift slide or a pivot door, which is also manufactured.
It's a minor detail, but it's the same clear anodized on the track as you can get on the aluminum extrusion, so everything matches.
That's a good detail for us. Over in this section is actually where you're going to start seeing these pieces come together.
Yep.
The piece you were holding at the bench was not snapped together. That is done on a machine. You can actually see this being pressed here, where it's coming through the machine. This is where they're going to be mitering everything. They're creating a lot safer process where all automated. Those saws are moving essentially based on the length of that section. You can see working in front of him, he's got the cut list. That package of paper goes with the product as it comes in and moves with the components throughout the whole process. Everything that comes off of this line then gets marked up. And I think they said they use blue tape and even markers, and they essentially lay out where all the hardware, hey, I have a 5/8 hole that needs to be drilled here. I need to router out the aluminum for hardware in this specific location. And then the shift lead comes over and actually inspects that and compares it again to that worksheet and says, yes, we are all on the same page. This is where everything needs to be manufactured or machined. And then they're doing a lot of that by hand. There's a lot of people and a lot of handwork on these products.
This is a great example, actually. This is a custom press for the 45-degree mitered corners in all of their frames. And this is a pressure fit where the inside of that corner is crimped under a lot of pneumatic pressure, creates a inseparable joint, and you don't have the outside lines of a butt joint.
I'm gonna make myself at home here and grab one of these pieces for just a moment, and I'll put it back, I promise. When it comes off that saw, you can actually see how that miter is consistent. The wood gets cut, all the plastic gets cut, and the aluminum all in one shot. And what I was talking about over where they're doing some of the handwork, there's someone that grabs a biscuit joiner off the bench and puts a biscuit there. So when this product comes onto this machine, they're essentially putting a crimp block. You have some other alignment clips, and then they're epoxying all of that together with a marine epoxy, and then of course wood glue. And when that goes in, it's putting a tremendous amount of pressure in creating an inseparable miter, which was something I had brought up. Is if you're
How do you make that so fine and you don't see any movement on these over time?
Then I noticed that there's a ton of squeeze out, and you're talking about a finished surface here that, you know, the black paint.
And one of the things I noticed when we were walking through this shop is there's really no odor. You don't smell anything. So I was like, well, how are they handling that cleaning epoxies? And they're not using xylene or acetones. They're using a vinegar solution.
You know,
working in California.
Working in Oceanside and saying we need to find something that allows us to clean this and not be in a position where they have to glue it and then finish it, because now you're
adding
decreasing.
a step out of sequence and you're not going to have that level of precision.
Exactly.
Yep.
You think that you could build a machine that's doing everything at once, but they were really specific. It's one corner at a time.
You get one perfect 45 at a time and rotate it around.
And it really allows you to hyper focus on the integrity of that. So that frame goes over to a pair of sawhorses. They clean it up over there, and then it goes over here. This is where stuff starts getting assembled.
The caster tracks are being installed. The hardware are being installed.
We're looking at lift slide units, so it is exactly what it sounds like.
When you rotate the handle down, shifts the casters out of this base. At that point, the bearings they're on are really high quality, and it's easy to move a unit that could weigh, you know, north of 500 pounds.
When these wheels are up, the door is essentially locking itself by the weight of it.
Yeah, so from a building performance perspective, it's locked not only by the weight, but the gaskets are under that load, and so you have a multi-point seal that's much tighter, less air infiltration, and higher performing connection.
So hardware is in. Before they get glazed, they get tested.
Andersen tests them one more time to the RO dimensions, and they built another machine specifically for that check.
I want to be very clear when I say this. Every single unit gets tested. And I'm not going to stand behind this yellow line because we're not allowed to.
Right.
But every single unit that gets manufactured gets tested.
Yeah, so they're setting and this gives you a sense of how large of a unit they can make. They're adjusting this to the ROs on the shop drawings. It's not possible for an assembly to leave that doesn't match the RO requirements.
Right. They don't put the glass in really just from a manhandling perspective.
Yeah, because you can move these by hand. You don't have to get
the units
lift.
Can't flex. They're not relying on the glazing from a structural standpoint in terms of like operating here. They're putting the screens, the doors, everything in.
All the components.
Making sure it works. So once these are done, unfortunately, they come back apart, and then the tracks go into a shipping crate. It gets packaged, it gets labeled, and it gets ready for freight. But when those tracks get packaged up, the panels actually go to glazing.
And this is another great example of the handwork that goes into all the silicone glazing into these.
Before the handwork, they're using the smart lift again, grabbing that glass and using that to set. So they end up on these, what used to be sawhorses, are now carts, but they're setting that glass in here. Sometimes you'll see wet glazing where they would actually run a bead, drop this in. Instead, this is being dropped on a gasket.
Right, and then glazed over.
And you're getting that seal on the gasket.
It's partially aesthetically it looks nicer to do it this way, but it's very much a performance difference.
Yeah, so this glass gets in, they'll put an aluminum cap on that, that's the inside there, that then gets capped with your wood trim, which we're seeing here.
Yeah, and this gantry machine with the webbing picks it up, flips it, trim can easily be installed on both sides, and then carted down to a glazing table.
If you can envision this wood cap here, that's about 3/4 by maybe 1.25 inches, this actually snapped over an aluminum cap that's holding that glass in. And then like you said, this will slide over, the straps will go in, it'll rotate it, and then we have a unit over here. And this is a 2-part silicone. One gentleman goes around this unit,
runs a bead,
a really healthy amount of silicone into that reveal, and then they have, I'm just going to call it a specialized tool that they made to give a nice consistent bead all the way around the unit. So you're getting that hand touch. It gives you the opportunity to really detail it really well and not rely on a machine to do it.
The caulk line is perfect, and you get a mechanical connection and a lot of overlay on the silicone for that seal.
This silicone was something that they improved, and it only takes about 45 minutes to set up.
Yeah.
They used to have units stacked out here at night and basically wait all day or potentially 2 days for them to be ready to be packaged up and shipped. And if you can grab that sheet back there, that's an example of kind of how they
shipping material they've created. It's almost as masonite the thin foam layer on the interior.
All of those seams where you can
Fits each module of frame that they have.
From here, guys, like this is kind of the end of the line of the manufacturing, and then you'll start seeing everything start being shrink wrapped, crated up, and whether it's being locally shipped or shipped across the country for our Echo Pond project, there's a tremendous amount of hand that goes into this, but doesn't sacrifice the efficiency.
There's a lot of options in windows and glazing and doors, and the ability to go to larger format lift slide units that are still handcrafted, hand assembled, and are adjusted to all the different jurisdictional requirements in the United States. The nearest comparable products, they're all imported.
So I want to wrap this video up. I want you to stand next to that 16-foot by 10-foot door. Let's do that. So I'm 6'6" and he's 6'2".
On a good day.
It's a pretty tall door. I hope you guys enjoyed the Oceanside factory tour with Andersen Windows. See you guys next time.